we are going to start some standard forms, some special type of partial differential equations, and the first form is where the equation involves only p and q. F of pq equal to 0. We have the equation involving only p and q. So for that, the Charpit's equation reduces to, okay, first one is this second, third ratio, and fourth will be dp divided by 0. Why? Because here fx is also 0 and fz is also 0, because our equation is involving only p and q. So when derivating f with respect to x, we get 0. Derivating f with respect to z, we get 0, right? So these two denominators are 0 in these ratios. So our Charpit's equation reduces to this. And then we need to choose our dp to be equal to 0, this ratio to be equal to 0. That implies when integrating both the sides, we get p equal to a is arbitrary constant. And from here, just put this value in the given equation, and you will get the value of q in terms of a, the constant a, right? And then last step is to use dz equal to p dx plus q dy to get the complete integral. So these are the steps for the equations involving p and q. So let's move on to one example. Find the complete integral of these three parts. So first one is pq equal to 1. Now you have seen that the equation involving only p and q variables, right? तो इस equation में सिर्फ p और q variables दिखेंगे आपको. So first we take our f to be equal to, I am taking this one to the other side. This is pq minus 1. And from here we get fp, that is derivating f with respect to p, that will be q. Derivating f with respect to q will be p. That's it, right? And now we are going to use the Charpit's equations. So for the exam, you write all these equations. So here we only consider this ratio, right? Because we have fx to be equal to 0 and also fz to be equal to 0. So I'm writing here, you can also consider this one, but here I'm going to consider dp divided by 0 to be equal to 0, which implies dp equals to 0. And when integrating both the sides, we are getting p to be equal to a, where a is a constant. You can take any ratio to be equal to 0, right? Okay. And then we need to get the value of q. What is our given equation? It is pq equal to 1. So from the given equation, we are getting the value of q to be equal to, just put the value of p over here, we get, and then q is equal to 1 divided by a. So we have got the value of q in terms of a. Now we have to use the equation dz to be equal to p dx plus q dy to get the complete integral. So dz is equal to a dx plus 1 divided by a dy. Integrating, we get z equal to ax plus 1 divided by a into y, the constant b. So z equal to ax plus y divided by a plus b is the required complete integral. Similarly, the next example. So here also we are taking f to be equal to p plus q minus pq, right? And now by the Charpit's equations, I have considered the ratio dp divided by 0 to be equal to 0, right? Or you can straight away write that by Charpit's equation we have dp to be equal to 0. But in the exam you have to write all the equations, you have to write all the details, right? Okay. So from here we are getting p equal to a, where a is a constant. And from the given equation, I am going to put the value of p over here to get the value of q. So this is a plus q to be equal to a into q. So from here we get a minus 1 into q equals to a, and q is equal to a divided by a minus 1. And then we use dz to be equal to p dx plus q dy. So dz is equal to, the value of p is always a, right? Dx plus what is q? It is a divided by a minus 1 dy. And when integrating, we get z to be equal to ax plus a divided by a minus 1y plus the constant b. So this is the required complete integral where a and b are constants, arbitrary constants. So in these types of equations, we always have p to be equal to constant a, right? The equations involving only p and q. Last part, p square plus q square to be equal to 1. So straight away take p to be equal to a, where a is a constant, and from the given equation we have a square plus q square to be equal to 1. Put the value of p over here and we get q square to be equal to 1 minus a square, and q is equal to the square root of 1 minus a square. And now we need to use dz to be equal to p dx plus q dy after getting the values of p and q. So dz is equal to a dx plus the square root of 1 minus a square dy. And integrating both the sides, we have z equal to ax plus the square root of 1 minus a square y plus the constant b. So this is the required complete integral of the given equation where a and b are arbitrary constants. Easy? Yes, easy to solve. Alright. So in the next content we will be doing more examples based on this. Okay, thank you.